to talk about Micronaut data today. And for those who don't know me, this is me. I don't know why I put a picture of myself on the slide when I'm standing here, but that's me. I'm a full stack developer. I've been so for 16 years. I live in Blairsville, Georgia, which is 2 hours north of here. They're on a snow day today, so yeah, they had worse weather than we get down here in Atlanta. And I am a Java, Groovy, JavaScript, TypeScript, Angular, pretty much anything you could think of except for like PHP I've tinkered with, and tend to use more Java nowadays now that I work for Oracle, but that's okay. This is a Java conference and Java is an awesome language, so I do tend to like dynamic languages a little more, but Java for what it is probably the best there is at what it does. And I'm a developer advocate for cloud and cloud databases at Oracle. But today I'm going to talk to you about something a little different, and that is Micronaut data. And we're going to talk about what it is, a little bit about how it does its magic, and mostly we're going to use it. I'm going to show you through a lot of, like, an obscene amount of live coding, so the potential for on-stage disaster is very high in this talk. But actually, I've got a lot of snippets as backups too, so we should be okay. So what is Micronaut data? If you go to the website and look at the documentation, there's this very well-crafted statement that explains what Micronaut data is. And basically, it's this data access toolkit that uses ahead-of-time compilation to pre-compute queries for repository interfaces that are executed at runtime by a really thin layer. Now that's kind of, like I said, a little bit of marketing speak, so let me break it down a little bit more. Basically, it's a way to generate boilerplate SQL code for CRUD operations and more, not just CRUD operations, but it's a tool to make your life easier. If you were in my talk yesterday, I tend to use this analogy or joke often. One of the very first things you learn as a programmer, as a web developer, is how to write a SQL query. And one of the second things you learn is how to avoid writing SQL queries, right? Nobody likes writing SQL, especially for boring boilerplate CRUDs, select star from user where ID equals. That gets redundant and boring really quick. So I like to find new ways all the time to avoid writing SQL and still get the same performance, still get the data I need, no compromises, and Micronaut data is a way to do that. If you are familiar with GORM or Grails, it's very similar to GORM, but the advantage of it all being done ahead of time at compilation time means there's no runtime errors, there's no meta model, there's no query translation. Your performance is going to be excellent when you're using Micronaut data because you're not storing all that metadata in your RAM, and you're not doing query translations at runtime, things like that. Again, there's no reflection runtime proxies. This is built for microservices, right? Everyone's doing microservices nowadays. They're deploying them in containers on Kubernetes or whatever other solutions they're using. And we want really quick startups. We want really low memory utilizations. That keeps our cloud bills down, and that makes the people that pay the bills happy. The other awesome thing is that it's type safe. Since it's all done at compile time, if you make a mistake, if you mistype something, if you use the wrong case, it's going to be caught at compile time. There's not going to be any runtime errors. So if you used GORM a lot at all, and you mistype something, and you run your app, and you try to use that dynamic finder, why doesn't this work? Find by title doesn't work. That's because it's doing that at runtime, and when you do it at compile time, you can catch that, you can avoid those runtime errors. And finally, it is available in two separate flavors, a JPA flavor, which is kind of Hibernate-esque, and a JDBC flavor. We're going to look today at the JDBC flavor because I find it a little easier to understand, especially if you're new to the whole concept. And I just think it works really nice and it's really easy to learn. So how does it work? The first thing that you do with Micronaut data is you define an entity. So this is nothing new to you, right? You have POJOs, you have model objects, domain classes, whatever you want to call them. You define your entity. The next thing you do is you create a repository. And a repository can be an interface or an abstract class. We'll look at mostly the interface implementation today, but if you need to get granular, you can go down to an abstract class. And then you compile, and at runtime, like I said, the query is, at compile time, the query is generated, it's stored in annotation metadata, and available at runtime. And step 4, of course, is you profit, right? So if I could explain it to you in a single slide, I think this would probably be that slide. So put simply, a repository interface that's properly annotated and extends one of the built-in repositories in the framework will be automatically implemented by Micronaut at compile time. So all of the necessary queries for basic CRUD operations, as well as any custom user-defined queries in this kind of dynamic syntax, well, not dynamic syntax, but this find by syntax, will be computed and, like I said, made available at runtime via the metadata. So I've done a little prep work to get the app started just because it's kind of boring to watch me generate an app. And what I've done ahead of time is the following things. I've run the Micronaut create app CLI command, and that just generates an app for me, gets me ready to go, lets me move forward with my application. The next thing I did was added some dependencies. I'm not going to go through every single one here, but what you see here is the Micronaut data annotations, the Micronaut data dependency, and then my database driver, things like that. I added JPA so that I could use the JPA annotations. You don't have to do that, but I like to do that because they're kind of familiar to me. And then since we're going to ultimately deploy this as a native image, I made some changes to my native image properties file, added the line 4 and 5 there because that's required by Graal VM to generate the native image. And the next thing I did ahead of time is added a data source in my application.yaml file with a URL, the driver name, username, password, your standard kind of data source. So let's actually dig into the code. And as I said, there's a lot of demos here. So I'm going to show you the first example here of creating a domain model. So you can all see that really well, I hope. Yes? Cool. All right. So this is my build.gradle file. I'm going to hop over to my Project Explorer and let's create our domain model. And as I said, this is nothing really new. We've all created beans before, but I do want to show you it because I can do it pretty quickly, and I want to show you what's required. So in my constructor, I'm just creating a book class here, which is what's used in the documentation if you go to the Micronaut documentation. But I find it to be a good example to use, so we'll use that. So we have title of the book, we have pages, and we have a published on. Let's add an ID annotation and a generated value so that we get auto-generated IDs. And finally come down here and create some getters and setters. All right. So again, this is nothing special, it's nothing new. You've all probably seen this before. The only thing you have to do at this point for Micronaut to understand that this is an entity it needs to manage is annotate it with entity. That's it. You could also, if you wanted to, use mapped entity. Like I said, if you don't want to use the JPA annotations, you can use the Micronaut annotations. Zach, is this only for JDBC, the Micronaut annotations? Can you? Okay. Sorry, I didn't mean to. This is my source over here. He's going to help me if I get stuck. So that's it. We created an entity. Micronaut data knows that this is something that it needs to manage. Let's go back to the slides and talk about repositories. So we created our application, added our dependencies, configured the data source, and created our domain model, let's talk about repositories. So Micronaut Data offers a few different interfaces that you can extend depending on your application's needs. We're going to look at mostly CRUD repository here, but you can do async, reactive, RxJava. Another one that's really nice is Pageable. That adds, obviously, if you could... That's all right. I didn't know. I thought there was, I don't know. Adds methods and things for pagination. So what if you don't want to use an interface? Like I said, you can use an abstract class. In this example, we can inject and use the JDBC operations interface to prepare and execute our SQL statements manually. So you can see up on line 4, I dimmed it out now, but we're injecting JDBC operations, and we can actually still get down to that raw SQL if we really wanted to get our hands dirty, if we had a report query, or we wanted to call a stored procedure, whatever we needed to do, we can still get down to that level. And keep in mind, though, when you extend the CRUD repository, you still get those baked-in CRUD methods that we're going to look at in a minute here. So let's create a repository. It's really easy again. So we'll hop back over to our code, and we'll create our repository. And call it make it an interface. And so we simply extend CRUD repository book long. So that's our managed entity and the type for our ID. And oops, what is that? Come up here, and we annotate that with JDBC repository, and we tell it the dialect that we're using. This way it knows what dialect it needs to implement our queries in. And that's it. Our repository is created. We are ready to move on. So, out of the box, if we were to run this application right now, we have support for the following methods: count, delete, delete by ID, update, save all, find by ID, find all. These are all ready to go because it knows by looking at your entity and looking at the properties, it can craft your query for you out of the box. Okay, compile time, all ready to go. You'll notice I have an asterisk down by update, and that is because if you're using the JDBC flavor, there's no concept of a session or dirty checking, things like that you have in Hibernate. So it doesn't know when you pass an entity to save, it doesn't know whether it's a new object, or it doesn't easily know whether it's a new object or not. So you do have to define your update methods explicitly, but it's just a matter of, in your interface, writing the signature, passing the properties, saying which one's the ID, and that's all you need to do. So that's the only one of the only main differences between the JDBC and the other flavor. All right. Let's actually move on to creating a controller and using the repository. So if we jump back over to our code, and by the way, at any time, if anyone has any questions, please just throw up your hand. No problem at all. So let's go over here, and before we create our controller, I'm going to create a file that I call bootstrap because I'm a Grails user, so I'm fond of that name. And we're just going to create a class that's going to run as a singleton, and we're going to add an event listener so that when the application starts up, we can scaffold out some data, get it in the database, and just have some data to play with. So let's create a constructor and inject our repository here. And then I have a little snippet here. And so at this point, we have a listener. As I said, when the application starts up, this event listener will be fired, and we can scaffold out some data. So to do that, we're going to call the saveAll method of the book repository, and we're going to pass it a list if you want to import that. There we go. A list of, don't forget my semicolon, a list of books. And we'll say book 1, book 2, book 3, and book 4. So we have not created those yet, so let's do that. So we'll say book 1. I have a snippet for that. Let me close this properties. Make it a little easier to read. So book 1, book 2, book 3, and book 4. And our imports. All right. Then down here, we're going to just say books created. So when our service starts up, it's going to create these 4 books and save them to the database. We come back over here, and now we can create our controller. And once again, we're going to inject our repo. And create a few controller methods. So we'll have a get method that gets all. And that's going to do book repository.findAll. We'll add, let's add a get by ID. And we'll add a post method so that we can save new books. And I think that's good. Let's add a delete method. Why not? So this way we can delete books by ID. Okay, so let's start the app up. Oops, I didn't import that. Do my import. All right, awesome. Let's start it up. And while it starts up, let me write a little snippet here that I have for some curl statements to make life easier. All right, while that runs and starts up, any questions so far? Things making sense so far? Pretty simple to understand so far? I mean, there's not much to it. You create a repository, you annotate it, you have CRUD out of the box. You know, is everybody familiar with Micronaut? Have you used it before, learned a little bit about it before? Somewhat, some, yes, no? Okay. All right, let's see here. Of course, since we're doing a demo, it's going to take 17 years to compile and run the application. Wow, this is a new one. Well, yeah, that's what I'm trying to do here. I have a configuration set up, trying to run, done this a million times. Connected to the Wi-Fi. I've already ran this application, there's no errors. Well, this is not ideal. That's how it goes, right? Let me try one thing here. Let's quit everything else. Man, that's not what the plan was. Say again? I'm not even getting compilation errors. It's just like hanging. I've never seen this before, so. And I've already, like I said, I've already compiled this, so it's not trying to grab any dependencies right now. No, I sure don't. Well, we're going to move on here. We're going to move on, and hopefully at some point it decides to catch up. But maybe we'll just write code and not see it working. Sorry about that. So let's talk about queries. So custom queries in Micronaut data are kind of inspired by the dynamic finders in GORM, which themselves were inspired by the dynamic finders in Rails. And they follow this kind of convention that you can use, and they usually start with, they're broken up into what are called stems, and the first stem is usually find, but there are synonyms that you could use like query, search, etc. But I like find, so we'll use find. And the format of the dynamic finders kind of looks like this. Some of these things are optional, but essentially you're going to do find X, which is optional, and we'll explain what X is in a minute, by Y, order by Z, right? So what am I talking about here? Like, for example, you can do things like find by pages, order by published on. Find by published on, order by pages, things like this. You can structure queries in this manner, in this convention, and Micronaut data knows at compile time your intentions, and it will implement it as such. You can also add what are called projections, so you can do things like find title by pages, order by published on, if you just wanted a list of strings containing the title, for example. By default, you get pages equal, but you can also do other things like find by pages greater than, less than, contains, pretty much any operator that you can imagine in SQL. There is a convention that you can use to add a suffix to use that convention. For the ordering, you can also add ascending or descending. So it gives you this really kind of declarative, flexible syntax that you can use to craft custom queries. And essentially that last example boils down to this at compile time. Select title from book where pages are greater than a parameter, and then order by the published on date. There are other patterns that you can also use, like count by, exists by, delete by, so on and so forth, to do pretty much any operation that you can imagine. Let's write some custom queries, even though they probably aren't going to run. You can laugh, it's okay. My failure is for your pleasure. Happy birthday to me. Oh, you know what, let me, so we're going to create a repository. No, I already have a repository. We are going to go back into presentation mode. We're going to open our repository. And let's write some queries. So if we wanted a list of books, we can, as I said, do find by pages greater than. And then we just tell it what to expect as a parameter. and we get select all from books where page is greater than X. So as I said, we can do other things like find by title like. So if we wanted to do a search where it contains the title, we could do that. We can also do find by title I like for a case insensitive like, which is my favorite. And as I said, we can do, if we wanted just a list of strings, we could find title by title I like. So that would just give us back a list of strings. Let's go over to the controller then and show you how I might use one of these. Yes? Yes, I do. I don't know if that would keep it from compiling, but thank you. So I do need to annotate my controller with @controller, and perhaps that was the problem. I sure wish it would have told me that, but I digress. So if we wanted to, again, get by title, I'll add a title annotation, our title controller method, and then use that method we just added. So we say find by title I like. All right, let's try that one again. Yeah, and you know, I just was on the mailing list last few weeks ago when I was rehearsing this, and it tripped me up because I totally forgot that you had to, and James, one of the Micronaut guys on the team, is like, yeah, dude, you gotta add percentage signs. That's how it works. So I felt so dumb after that, but you do have to add the percentage signs because, you know, you might want to just match the end. You might just want to match the beginning, right?
Does he do more control?
Yeah. You know, so that's that. Let's try one more time to destroy Java and see if it's. Yeah, that might be not a bad idea because I really don't need the debugger. So let's just run this guy. I feel like the jet fan running on my MacBook right now, so I don't know, it's not happy about something. I've got everything closed other than what we're working on here, so let me just close my terminal just in case there's something hanging in there, but there is no joy. I'm going to try just for fun. Kill that, and let's just destroy IntelliJ and start it over. Any other questions? Who's from the farthest place from here? Who traveled the farthest to get here? Anybody? Nobody? Huh? Hawaii, did someone say?
I thought you were from Wisconsin.
Wisconsin. Did they bring any cheese or beer? Yeah, I think if I was from Wisconsin, I'd enjoy this temperature as well. I was actually born in Cleveland, Ohio, and they're not getting the greatest weather up there right now either. Just trying to keep talking here and kill time. California, okay. Huh? This is just flabbergasting to me. Have you ever seen it hang like this? Am I? Oh, I'm an idiot. Let's just try a run. Do I have a typo in my Gradle file?
You know, sooner than that. You do the text template
Where is it? I don't even see it. It's not there. Fantastic. What's that? Oh, it says it's running. Yay. It was worth it, wasn't it? All right, so if it's running then, we should be able to do some curls. Oops. All right. Connection refused. Oh, it's not 8081, that's why. All right. The patronizing clap. Good job, you did what you're supposed to. So the find all method, just /book, is going to give us a list of books here. Let me copy my curl command. All right, so we can create a new book by making a post to the save endpoint, and that returns our new book. If we do a list again, we can see ID number 5 is brand new down there. We can also, as I said, find a book by ID. So if we just add /ID at the end of it, we get a single object back with the book by ID. And
Clear the screen because I can't see that there here. Can they see what actually you're in?
sure thing. All right, where was I? So we can also delete by ID, and it gives us no content back. But if we do a list again, we can see that number 5 is gone. And just for fun, let's do a search by title. And this again is a like search. And if I say SE, it finds the titles that are like SE, titles that contain SE. And that's where we're at so far. Back to the code, back to the slides. So you can also, you don't have to do that dynamic finder type sequence convention. You can also simplify things and just say find, and Micronaut data will use the properties that you pass in to construct your query. Instead of using it in the method name, you can pass them and it will craft it that way. It's a little less flexible, but some people might find it a little more readable. So again, it's up to you, which way you want to go with it. So the other thing that you can do that's really cool is DTO projections, right? So if you have these huge objects, sometimes you don't want every single property coming back with your entity. You might just want a single property. So in that case, we can construct a DTO, and basically it's just a POJO. It's annotated with introspected, not entity. And then if we create a getter and setter, at this point, we can come back to our controller. Nope, we can go to our repository. And instead, for example, for this method here, this find by title I like, we can return a list of book DTOs. Just because we're running short on time, as you can imagine, if I were to run this right now, you would get an array of objects, but there would only be one property. There would be a title property, right? There wouldn't be the pages and the published on date. So it's a nice way to use data transfer objects if you want to just limit what you're returning back to the client. What's next? Explicit queries. And I luckily am not going to show this as a demo, but essentially if you want to, even in your interfaces, instead of dropping down to an abstract class, you can annotate with @query, and you could pass a query in. Again, if it can get kind of, if you have a really complex query, you might not want to do this because it's going to not look very nice. But for simple things, in this case, where we're doing a find by book title and limiting to 5, we can annotate it like this, and that would work. There's other query support like join queries. So if you have associations, you know, one to many, many to one to one, you can annotate with @join. You can do soft deletes, which is really, really nice. So on your entity, maybe you have an enabled or, you know, active property in your entity, and you use that to soft delete things. You can say @where and then the where clause for the active entities, as it were, right? So that way, the default queries, the default finds, find alls, will honor that where clause and apply that to every single query that it runs. So it's just a nice, easy support for soft deletes. You can also obviously override that, and if you wanted all your users, you just write a query for that. For JPA, if you're using that flavor, you use that JPA-QL style explicit query, and as I said, you can do async queries, reactive queries, RxJava. All that support is there. That link is impossible to read on the bottom of that slide. Pagination. Let's talk about pagination. As I said, if we change our repository to a pageable repository, we can then come over to our controller and add another method really quickly, and we just need to know the offset and the max, right? So we add those, offset max, pass them into the method, and we can call book repository. Wait a minute, what are we doing here? Book. What do you not like here? Book repository, find all. So if we call the find all method this time, it's going to expect a pageable object. So we can use the pageable, and it's going to want the offset and the max. So we say pageable.from offset max. Oh, what's the squiggly lines for? Say what? Oh, I sure do. All right. So if we run that and we pass /0/1, it would limit. And it also return, again, we're running short on time because of my mistakes or issues, but it would return some more information like has more, current page number, total available. So it'll return some nice information for you back with an array of items that contain the 0/1 objects, right? Native image. Let's talk about Graal native images a little bit. So again, microservices, we're in this world where we want small, lightweight, fast startup, low memory consumption, beautiful, amazing world of Java that we've now entered in. And Graal native images are a way to do that. The Graal project actually has 2 sub-projects. Well, it has more than 2 sub-projects, but I want to talk about 2 sub-projects of the Graal project. The first is a just-in-time compiler. So it has this just-in-time compiler that they've added that changes the way your apps are compiled and at runtime and improves performance of your application. And in fact, if I'm not mistaken, Twitter has actually implemented this and has had a great deal of success in how they've implemented it to lower their costs, their server costs by, I think, 10–15%, just because of the performance gains that they've gotten from using the Graal just-in-time compiler. So I created this very simple app, not this one that we're looking at, but a while back I created a very simple Hello World Micronaut app, and I did a load test on it. So I sent like 500, 1,000 users, and I did it over 60 seconds. And this graph using the just-in-time compiler should look probably familiar to you if you've done any Java profiling or anything like that. You see some massive spikes. You see some, if we look at the axis, 100% CPU. Sometimes our Java apps can be kind of memory hogs. And the memory across the top, we're using about 325 megs of RAM. Not terrible, not great, just an average kind of expected view of a Java app. When you look at an AOT, the Grail native image, the ahead of time compiled Grail native image on that same test, same application, deployed as a native image, you can see a few spikes still in a very steady line of memory consumption, but if I show you the axes, it looks much different, right? That's 1%, not 100. That's 75 megs of RAM. So this same exact service deployed as a native image is using 75 megs of RAM and 1% over that same exact load test with that same application. So it's, again, a huge benefit that you can use Grail to run your applications as a native image. And to do that with Micronaut data, you assemble your application into a jar, and then you run the Docker build bash script that comes out of the box scaffolded for you. And that will use this Docker file that you see here. It uses the Grail, on line 1 there, the Grail Docker image, and it installs the native image plugin, and then it runs the native image and compiles a native image from your jar file. It still has some wrinkles sometimes, depending on what dependencies you use. It can be kind of tricky, and in fact, the Micronaut data documentation has a few gotchas in it about when you're using Postgres and MySQL, I think. There are a few things you have to do ahead of time in order for the native image to compile. Now, this can take some time. I mean, 60 seconds plus it could take to create this native image. But if you look at those charts and compare the performance, I'd rather wait that 60 seconds sitting at my desk drinking coffee than have my application have that penalty every single time it starts up. So finally, we use a scratch Docker image, copy in our native image, and set an entry point that will be used when you run the application. I've already done that, and we could run the Docker image, but I'm afraid of more disaster, so we'll move on to transactional events. So transactional events is another thing that you can do with Micronaut data to kind of put in some hooks for obviously events that happen when you're working with your application. So if we come over here and we say create a new class, and in this case we're going to create a book manager. And in the spirit of time, I'm going to use a snippet to create that. And so what we have here is a book manager, and I have some properties, some variables defined up top. I'm injecting my book repository, and I'm injecting this application event publisher, and I'm creating a REST client, and this is so that I can use the Ring Central API, just because, you know, every time you create a new book in your application, you want to receive a text message when that happens, right? You know, or whatever. You know, if you're a new user is created or a new order's been placed, if you wanted to receive text messages, you could use an API like this to do that. And it's just to demonstrate that basically down here we have this save method. So this book manager uses our book repository to save our book, and then it uses that event publisher that we injected to publish a new book event. And if you look down here, it's just a static class that contains the book to the event publisher. And then we return that book. Then we have this transactional event listener. And this is just a method called onNewBook that will receive that new event anytime that event has been published. And then, like I said, in that we just print out what book was saved. We craft our SMS message using Ring Central, and we add some parameters to from the message, and then we send the message. So every time a new book was created, we'll get a text message from this. So to use this, if we come over to Bootstrap, we can inject our book manager. And now that we have our book manager injected, we can create a book 0. And use our book manager to save the new book. book 0. And just for fun, we're going to try to run this guy. Why is that the debugger? All right. So our new book was created, and I got a text message saying that a new book was created. Actually, I can show you that real quick. Well, so you can see down here, service started, book, it logged out the book, it gave the message status, we're experiencing slowness, and there it is. A new book is created with ID 1. Awesome. Let's go back to the slides. So we talked about native images. So I've been using H2 in this demonstration, which is an in-memory database, which is really nice. It's helpful and handy, but obviously in the real world, we need to connect up to a real database. And to do that is really, really simple. We just need to add a dependency for our proper driver. Which we can do with just by adding the dependency. We can then switch our type hint on the application class to the Oracle driver. And then if we come over here, we can switch our data source to the Oracle database. Right, so at this point, if we were to rerun our application, I don't know the keyboard shortcut for run, I just know it for debug. What is it? So now we can come over to our database tab, and we got an error. Invalid character. That is true. You want to come up here and give the presentation? You're doing much better than me. So we do have to change the dialect as well on the repository. Awesome. So we can see now, this is my actual Oracle database. If we query that table, you can see the brand new book that was just created. Awesome. So extra credit, we can add JSON support. I'm not going to do that because we're running short on time, but I will show you how that's done. So if you have a database that supports things like JSON columns, you can add a type def on the property in your entity for datatype.json. And the other cool thing to show here is the column transformer. So Micronaut data allows you to do transformations on read and write. In this case, since Oracle database stores the JSON documents as blobs, we can on read convert that to varchar, and then on write we can cast it to raw. So that allows us to do transformations. Maybe you have for whatever reason you wanted to do uppercase on every read, you could do things like that. So column transformer is a nice way to do that. And then for JSON support, you just declare it as a map or a list or whatever the JSON document is, and that's what you'll get back with your entity. So in summary, despite the failures of my demo early on, I hope that you learned that Micronaut data is a really powerful and really cool way to get data in and out of your database. I've just barely scratched the surface, even more so with the failures of what you can do with it. There's much more you can do. Like I said, the full JPA support is there, and I really encourage you to take a look and check it out and read the documentation and try using it in your applications. Thank you.